of the discussion of the system.
But you can't, because you can't discuss the system as being dependable on the observer. Now, the reason why you can't say that is because these systems, even though regardless, we still end up with three, right? Or four systems, as you see, these lines are different, right? Whether we end up here now with three or four systems, right? Whether they are observable or not, we still have three or four systems, right? So for this, because we're running out of space, we will just write same, right?
Because if you're in a closed universe, there's nobody outside the universe. And so we interpreted the 0 degrees of freedom as saying that
But it's not 0 degrees of freedom because these are measurable. So they have to equal same. They can't equal anything else but measurable degrees of freedom. I can't see that you're in this black hole, but I can measure this black hole's radius, size. That's it. That exists. That's there, right? I can't see you. You might see me. The fact is that that's still a system, whether it's closed or not. All right.
nobody can measure a closed universe from the outside. You can only measure it from the inside.
Well, that's not true at all. You can measure a closed universe by being able to measure a closed universe by measuring it. Now, like, well, if it's not measurable, well, how do you measure it? Well, you, as I said, you take its distance, right? We go back to fucking square one. You take its distance and you apply a constant, and then you add that constant to Einstein's equation, in which applies it to mass, which applies it to weight, which applies it to joules, which creates it to an equation which determines that it's a system. So regardless, we add on to this, right? You're afraid to create an unstable system, right? That's the problem here, bud. You know. But okay, go on.
And so we proposed a way of doing calculations.
But to me though, right? So this is all right. So where are we right now?
In the one-dimensional Hilbert space based on this
Cobalt
picture of the
60.
code where you have an encoding map from an effective to a fundamental Hilbert space, here with the fundamental Hilbert space being one-dimensional.